Hello, my name is Alvin M. Evangelista, BSHM, and today we're going to discuss and solve changes for a quarter, the math behind counting coins. For our introduction, the problem of making change for a quarter using dimes, nickels, and pennies is a classic example for a combinatorial problem in mathematics. It involves finding all the possible ways to combine these coins to make 25 cents. In this presentation, we will explore different methods for solving this problem and discuss some interesting insight that can be gained from it. Our first one is brute force method. One way to approach this problem is through brute force, which involves listing out of all of the possible combination of coins and checking if they can add up to 25 cents. For example, one combination would be 2 dimes and 5 pennies, which equals to 25 cents. Another combination would be 1 dime, 2 nickel, and 25 pennies, which also equals 25 cents. By listing out all possible combinations, we can find the total number of ways to make change for a quarter. For the second one is generating functions. Another method for solving this problem is through generating function, which involves representing each type of coin as a polynomial and then multiplying them together to get single polynomial that represent all possible combinations. By expanding the polynomial and looking at the coefficient of the term corresponding to 25 cents, we can determine the total number of ways to make changes for a quarter using dimes, nickels, and pennies. Recursion. Recursion is another powerful tool for solving combinatorial problems like this one. In this approach, we can break down the problem into smaller sub-problems and use the solution to those sub-problems to build up the solution to the original problem. For example, we can start by considering all the possible ways to make change for 25 cents using only pennies. Then we can add up the possibilities for using nickels. And finally, the possibilities for using dimes by recursively building up the solution to these smaller problems. We can find the total number of ways to make change for a quarter. Next one is insight and applications. Solving the problem of making change for a quarter using dimes, nickels, and pennies can provide valuable insight into combinatorial problem in general. By studying the different methods for solving this problem, we can gain a deeper understanding of combinatorial structure and these properties. Furthermore, this problem has many practical applications, such as in the design of vending machine or cash registers. By understanding the different ways to make change for a quarter, we can optimize the design of this system to minimize the amount of coins needed for each transaction. As you can see, we use the brute force method to know how many ways of the pennies can do. So, the to calculate the number of ways to make change for 25 cents using dimes, nickels, or pennies, we need to consider possible combination. Here are the different ways to make change for 25 cents. The first one is using 25 pennies. It would be equal to 25 cents. The second one is using 2 dimes and 5 pennies. 2 dimes is 10 cents each and 5 pennies is 1 cent each. So it would be equal to 25 cents. For the third one is using 1 dime, 2 nickels, and 15 pennies. 1 dime would be 10 cents, 2 nickels would be 5 cents each, and 15 pennies would be 1 cent each. So it would be 25 cents. The fourth one is using 1 dime, 1 nickel, and 20 pennies. The 1 dime would cost 10 cents, 1 nickel would cost 5 cents, and the 20 pennies would cost 1 cent each, so it would be also equal to 25 cents. The fifth one would be 1 dime, 15 pennies, and 1 dime. So that would be also equal to 25 cents. As you can see, there are 9 different ways to make change for 25 cents using dimes, nickels, and pennies. So in conclusion, the problem of making change for a quarter using dimes, nickels, and pennies is a fascinating combinatorial problem in many different approaches and insights. By exploring the different methods for solving this problem, we can gain a deeper understanding of combinatorial structure and their application in the real-world system. whether to the brute force, generating function, recursion, or other methods. The solution to this problem provides a rich source of knowledge and inspiration for mathematicians, computer scientists, and engineers alike. Thank you for watching.